This is Mission Control Houston. Good morning. You're getting a look at the Cygnus Orbital ATK, Orbital ATK Cygnus on its 9th contracted cargo mission to the International Space Station, now approaching the orbiting complex just about 2,000 meters away. Good morning. Today is May 24th, 2018. We're live here inside the International Space Station Flight Control Room. Sitting next to me is Chad Davis from Orbital ATK. He's the mission lead here in Houston. Chad, thank you for joining me. He's going to be joining me for the remainder of today's broadcast, talking about the Cygnus vehicle itself. But here today in the room behind me are the Orbit 1 team leading the operations today. Flight director for today's operations is Judd Freeling, sitting there in the center of your screen, red tie. Next to him, Cindy Kester, who's the Capcom for today's operations, will be communicating to the crew on the International Space Station. Visiting Vehicle Officer Mark Anderson is here in Mission Control Houston, speaking with NASA officials in Virginia, relaying vehicle status and updates to the flight director here in Mission Control Houston. Of course, over in Dulles is Orbital ATK Flight Control Team Operations in Dulles, Virginia, led by Mission Director Tony Foti.
Sorry for the trouble. I totally misunderstood the steps and I accidentally turned off the system, but now it's back on.
Copy that. There's no problem. We see good telemetry now. Thanks for fixing it.
You're hearing the voice of Norishige Kanai aboard the International Space Station right now. Of course, in the cupola workstation are two NASA astronauts that are at the controls of the station's robotic arm. Lead robotic arm operator for today is NASA astronaut Scott Tingle, assisted by Ricky Arnold. The other in the cupola workstation, of course, Norishige Kanai is at a station called the Cuckoo, which is a communications unit that provides telemetry data as Cygnus approaches the International Space Station. This is just under 3 days after the launch of Cygnus on top of Orbital ATK's Antares 230 rocket from Pad 0A at Wallops Flight Facility in Virginia, lifting off at 3:44 a.m. Central Time on Monday, May 21st. In orbit, solar arrays were deployed, and off it went. Now it's on rendezvous course just under 3 days later, carrying about 7,400 pounds of food, supplies, and experiments to the International Space Station. Today we're looking at a capture time at 4:20 a.m. Central Time.
We are manning the cupola and we're ready to go when you guys are.
Robo is ready, and we're right along with you.
Of course, plenty of science experiments that we'll explain along the way. 7,400 pounds of supplies on board Cygnus, many of experiments on board that we'll cover as Cygnus approaches closer and closer to the International Space Station.
Station Houston on 2 for Cygnus. We're expecting about another minute in the ADV-3 burn, about 1,500 meters away.
Okay, copy that. Thank you.
Station Houston on 2 for Cygnus. ADB-3 approach initiation burn is complete. Expect to begin using 1.102 Cygnus approach and retreat monitoring shortly when Cygnus range reaches 1,000 meters.
Cindy, thank you.
Of course, that was the voice of Sydney Kester, again, Capcom here in Mission Control Houston, speaking with the astronauts aboard the International Space Station. That was the voice of Norishige Kanai, who's looking at telemetry data as Scott Tingle and Ricky Arnold are inside the Cupola workstation at the controls of the robotic arm, waiting for the Cygnus to slowly start approaching. As you can see, this is a view from the Cuckoo workstation. There's a number at the bottom, sort of right of that telemetry data primary range of Cygnus to the International Space Station. You can see closing in, just about to pass 1,300 meters, slowly approaching a range of 1,000. Again, Mission Control teams in Dulles, Virginia. This is Orbital ATK's team communicating with the teams here in Mission Control Houston. A lot of work to prepare for today's events of capturing the Cygnus. Again, we're looking at a 4:20 a.m. Central Time capture today. Again, I'm sitting here with Chad Davis from Orbital ATK, who knows the Cygnus vehicle inside and out, and the operations, of course, leading the teams here in Houston. Now, a lot of work went into preparing for this capture, and you were here even earlier this morning. So what were some of the prep work that we did earlier today to get prepared for right now?
Essentially, what we're doing is we're coming in prior to pre-jobs. We're going through all the systems, finalizing our last set of Delta V burns, and then once we pretty much do a poll on the Cygnus side from MCC Dulles, as well as a poll with the ISS, we get the final go to begin joint operations. So at that point, we know both vehicles are healthy and good to proceed on in to capture day.
Now, the Cygnus vehicle itself has been orbiting the Earth for just about 3 days, coming up on it. But it's sort of interesting because when it's orbiting, it's not necessarily orbiting how it's oriented right now. So how is it oriented right now versus the way that it has been for the past 3 days?
Well, typically while we're in phasing operations, we do sun pointing, so that allows us to get the optimum sun focus on the arrays for maximum power, and then of course we have to adjust attitude as needed for possible spacecraft thermal conditions. And then once we get closer to the beginning of joint operations, we pitch over to what we call the LVLH, local vertical, local horizontal, which allows the spacecraft to be in a similar axis orientation to the ISS, and it optimizes the antenna pointing to the station, so we can do space-to-space communications between the two spacecraft.
So the LVLH, that's sort of parallel to the International Space Station. So when it's coming up, that's why you see it in that orientation, sort of matching the orientation of the space station. But other than that, it doesn't really need to fly sort of straight, right? You're actually facing the sun because that's where the most energy is.
Yes, when we're in the sun pointing orientation, we're optimizing the focus of the sun on the arrays. But once we get closer to station, we've got a good charge on the batteries, and then at that point, the primary focus is good communications with the station as we're performing the rendezvous.
Now again, Cygnus is approaching the International Space Station, about to cross the 1,000-meter range.
Station Houston on 2 for Scott and Cygnus. The range is 1,000 meters. Monitor long-range approach per step 1 in 1.102 Cygnus approach and retreat monitoring.
Step 1. In work, Cindy. Thank you.
Now, of course, that was confirmation from, again, Sidney Kester, Capcom, sitting there communicating with the crew on board the International Space Station, relaying a successful ADV-3 burn. Again, there's a series of burns, basically firing the engines to get the Cygnus closer and closer as the teams continue to monitor the health and status of Cygnus and the International Space Station upon its approach. Now, ADV-3 is a significant milestone, so, Chad, ADV-3, what's important about this particular burn?
Essentially, with ADV-3, we're transitioning from about 1.4 kilometers, and it puts the spacecraft on the glide slope, for lack of a better term, to come up the R-bar, which is our primary glide path coming into the ISS for the rendezvous side. So without the ADV-3 burn, we're going to continue right on by the station, and it's a critical burn in the whole phase as we step our way up. So it's always good whenever we have a good ADV-3 burn, and everyone's happy with the current trajectory going in from that point forward.
We're watching it as well, and we concur. Outstanding.
Now, reports coming from orbit. The Cygnus, you can see from the view of the workstation here, just closing in on 800 meters away from the station. Crew has a good visibility of the Cygnus vehicle as it starts to approach, witnessing the vehicle as it's getting closer to the station, reporting that it's looking pretty good from their view as they're continuing to monitor the health and status of Cygnus upon its approach, of course, after this important ADV-3 burn. You can start to see the view of the Cygnus from the International Space Station. Great view as the International Space Station orbits the Earth, now 261 statute miles above just the south of the Indian Ocean, just west off the coast of Australia. There's a few more burns scheduled before the range of the Cygnus is just closing in on the 250-meter holding point. The schedule as it exists now, the Cygnus should be arriving at that point sometime before sunset, and then continue operations just shortly after sunrise. Now, throughout today's broadcast, we'll be handing over communication from our tracking and data relay satellites that provide video and audio communication to and from the International Space Station. Now, just in a short handover of that video communication now. Again, we're approaching the 250-meter holding point. This is one of the many milestones to get the Cygnus to its eventual capture point, just about the order of 10 meters away from the station. That allows the robotic arm to actually reach out and grab it. Now, 250 is a milestone, and Chad, for what reason?
Essentially, once we get to the 250 hold point, we transition from our GPS navigation, which was from vehicle to station, over to our LiDAR system, which allows us to track using Laser Ranger as we continue in from the 250 on up to the 30-meter hold point, and then on into the 11 to 12 meters out for the capture point.
And we're almost at about 250 meters to go to get to that point. Of course, we're still about just under 550 meters away from the space station at a range just under 1 meter per second. Again, just about 3/4 of a meter per second on its way to the International Space Station. Slightly slower from its original course shortly after the burn, just earlier at the beginning of today's broadcast. Again, a great view of Cygnus. Again, the space station just under 260 statute miles. Still over the South Indian Ocean. You should be seeing the west coast of Australia soon. We're about to skim past just the northwestern coast of Australia over Indonesia here shortly. Of course, we just completed the delta velocity approach, delta velocity burn number 3, which, as we described, is very important to actually approach the International Space Station. Now, just getting confirmation of ADV4. Now, this is also a very important burn. Is it the last delta velocity burn?
Yes, correct. That's the last one, and then from this point on, we're going to be doing slight, we call them hair hops, as we work our way up the R-bar from that point on.
So this is that final burn. Again, this happened just at about the 500-meter mark. Now we're at 440 meters away from the space station and closing. The next milestone of Ken will be a range of 300 meters, crossing that point to approach that 250-meter holding point. Now, this is a view from the common berthing mechanism of the International Space Station. That's where the Cygnus itself will be berthed, again, to the nadir point, or the Earth-facing side. This is why it's pointing towards the Earth, of the Unity module, node 1. Again, the Cygnus is currently just under 260 statute miles, 256 now, statute miles above the Earth, just over the west coast of Australia. We're just crossing the 400-meter point, actually just crossing 370 meters now. Again, the next milestone range will be 300 meters. That gets us closer to the 250-meter holding point. The vehicle itself is named after J.R. Thompson, who was a leader in NASA. He was administrator for a while, and also Orbital ATK and Orbital Sciences before that. And Chad, you actually had the pleasure of meeting J.R. Thompson for a while and know a little bit about him.
Yeah, whenever I was working on the Orion launch abort system, I had JR come and visit our low bay area where we were assembling a NERT launch abort system for some acoustic testing, and then preparing the hardware for shipping to White Sands for the pad abort test. And he showed up bright and early one morning and introduced himself, and came out and just liked to see the hardware and see all the stuff that we were doing to put Orbital on the map with human spaceflight with the supporting the Orion program.
Now, of course, Orbital ATK, one of the customers that provides cargo to the International Space Station regularly, a player in the aerospace industry. Now, J.R. Thompson, a leader in the aerospace industry, passed away back November 2017. Now just crossing 350 meters, actually closer to 340, and closing on that 300-meter range, again to the 250-meter holding point. Again, lots of science on board, 7,400 pounds of science and supplies aboard the cargo craft. Many unique experiments as well. One of the ones that I would like to highlight is the Cold Atom Laboratory. This is an interesting facility that will make use of the space station's unique microgravity environment to observe phenomena that would otherwise be undetectable on Earth. Now, the Cold Atom Laboratory studies ultra-cold quantum gases. Scientists use the facility to explore how atoms interact when they have almost no motion, getting really close to absolute zero, due to such cold temperatures. Now, the microgravity environment of the station, matter can stay in a condensate form longer than on Earth, giving researchers the unique opportunity to observe these phenomena. We can call this the coolest experiment on the International Space Station. Cygnus is now crossing over the 300-meter mark, 294 meters to be exact, again on the way to the 250-meter holding point. That's the next milestone. Again, 7,400 pounds of supplies and experiments waiting on board for the astronauts to actually ingress, planned for later today, but capture again at 4:20 a.m. Central Time. Many investigations on board. We already talked about the coolest one, but there's another one that actually has to do with navigation based on the stars. This one's called the Sextant Investigation. Chad, you know a little bit more about this one.
Yeah, I thought it was interesting that the crew's actually taken up a sextant instrument like they used in the days of the sailors to navigate via the stars, and some of the from the Apollo days they use instruments the same to be able to verify the computers had them in the right location for their guidance. And they actually have a sextant instrument on board Cygnus so that the crew can use that and help them sort of test the abilities for emergency situations in Orion once it starts doing its deep space exploration activities and missions out to the gateway at some point.
Very important. Of course, they'll have the reliable instruments that will actually take them where they need to go and use the onboard computers to navigate. But it's nice to have that backup of navigating via the stars, just like in the good old days.
Exactly.
Now, again, a lot of the milestones are already completed. We've crossed 1,000 meters and done the delta velocity 4 burn, which is the last delta velocity board. Now we're looking towards those hair hops that Chad was talking about before, crossing the 300-meter mark. Again, the next checkpoint is this hold at 250 meters to assess the following steps to get closer and closer to the space station, to just about 10 meters away. So NASA astronaut Scott Tingle and Ricky Arnold that are in the cupola workstation at the controls of the station's robotic arm can reach out and bring on the 7,400 pounds of crew of supplies and experiments on board the International Space Station.
9494, and the meter is the Copernicus.
Those are all good numbers. Thanks, Drew. While I have you, I can also give you that the PCA pressure is 742.2 millimeter Hg.
Copy that and got that off the display, and that checks out. I read 742 on the multimeter.
Copy all, and we're hearing a good check.
I concur.
Now, again, just under 260 miles away from the space station. 250 is our next milestone. That's the point where the Cygnus will hold for a bit, as teams here in Mission Control Houston and in Dulles, Virginia, the Orbital ATK flight control teams assess the vehicle and move on to the next step. After 200 meters, they'll be go for departure and go to the next hold point, which is just 30 meters away from the space station. Space station and Cygnus getting closer to the terminator line of the Earth, crossing into an orbital nighttime. We should be arriving at the 250-meter holding point during the daytime. You can see from the view of the common berthing mechanism that Cygnus will later actually berth to later today after our capture coverage will come back on for berthing. But right now, the International Space Station, 252 statute miles, just crossing over the Philippine Sea and into the North Pacific, where it will enter an orbital nighttime. But again, 250 meters, looking at arriving at that point during the daytime here shortly. Hard to tell from this view, but the rate of approaching the station has slowed down significantly. We're actually under 0.05 meters per second, closing in onto the 250-meter holding point, just crossing 252 meters, slowing down ever so slightly to the 250-meter holding point gently before they start calling the hold and then assessing the progress here in Mission Control Houston.
Station Houston on 2 for Scott and Cygnus.
Go ahead.
Cygnus has arrived at the 250-meter hold point. Stand by for Cygnus transition to LiDAR navigation before performing step 2 of 1.102.
Copy.
Now you heard confirmation from here in Mission Control Houston. That was from here in Mission Control Houston. That was Cindy Kester confirming. That was Capcom confirming to the crew aboard the International Space Station a hold at the 250-meter holding point. Again, you can see from the views here the space station starting to cross over into an orbital nighttime holding. During the daytime, getting good views of Cygnus before we cross over into night. The call from the Capcom Sydney Kester was to switch, now that we're at the 250-meter holding point, to switch to LiDAR navigation. Now, Chad, what does that mean?
Essentially, we've been coming in using our GPS navigation up to this point, and at the 250-meter hold point, we go ahead and transition over to our LiDAR as our primary sensor. And then we've got also TRIDARs as well, and we have a primary as well as a secondary that allows us to go in case we were to lose one of those. You know, we've still got the ability with 2 of the 3 to proceed on in for a safe rendezvous. It gives us the redundancy that we always like to have in human spaceflight. I was going to say, and then for the LiDAR itself, you know, it's essentially a laser range rate that we're using from the spacecraft on up to the ISS. It's given us measurements as we go versus with our GPS, you know, we're using between the 2 GPS sensors between the 2 spacecraft, getting our range and range rates. So that helps give us, you know, higher fidelity in what we're doing as we're on the approach. And additionally, while we're sitting here at the 250 hold point, we also do a repress of a propulsion system, which, you know, our prop lead, he looks at and sees what the current pressures are looking like, and then if we need to do the repress, he'll go ahead and get permission to go ahead and do that. Otherwise, if we're in a good pressure already, then we'll leave things as they are and press on in from the 250 hold point. That's important from the standpoint of once we started joint operations, we went and we're only using our RIAs for controlling the spacecraft versus our larger engine we used back in the DV burn, our biprop system.
Station Houston on 2, Cygnus has transitioned to LiDAR for navigation. Confirm Cygnus 250-meter hold per step 2 in 1.102.
Station on 2, we can confirm all of step 2 at 250 meters, and in P1 lower outboard, we are just about on and on, maybe a slight offset to the starboard per block Bravo.
Houston copies. We like that report. If you have a status on the CP3 camera, we'll take it.
Yeah, and S1 lower outboard, we're looking about 5 vehicle widths offset the port side and 1 vehicle length forward. line is in the circle.
Houston copies. That's expected for now.
Now, of course, we have a good view of the Cygnus from the cameras aboard the International Space Station, holding again at 250 meters, but the crew aboard the International Space Station has a slightly better view, reporting good telemetry as they determine whether to go through the next steps and depart 250 meters. You're seeing a view again from the space station, 252 statute miles now over the North Pacific Ocean, crossing over the Terminator line. That's why you see the blackness. That's actually the Earth behind Cygnus. Cygnus is still illuminated from the sun, as it's only 250 meters away from the space station, currently orbiting at 250 statute miles away. Now over the North Pacific Ocean, we'll start to see that view getting dimmer and dimmer as we cross into an orbital nighttime.
Station Houston on 2, Cygnus and ISS are configured for approach inside the keep-out sphere. Expect approach to resume shortly, and stand by for the Cygnus PCS command checkout.
Station copies.
Holding at 250 meters for just about 9 minutes. Confirmation from here in the ground up to the crew members aboard the International Space Station at the controls of the station's robotic arm. Again, Scott Tingle. You're hearing the voice of Ricky Arnold, who's right next to him. Scott Tingle, of course, as the prime robotic arm operator. Ricky Arnold providing communication and telemetry down here to the ground. Just got confirmation that we're looking good at the 250 meter holding point. Now beginning the next steps to depart 250 meters. We'll give you a status update once we're on our way to the 30 meter holding point.
Station Houston on 2, Cygnus has resumed approach. Go for Cygnus PCS command checkout. Hold arm per step 3 in 1.102.
Station copies in work.
And just as we're about to cross into an orbital nighttime and the views from Cygnus start to get slightly dimmer, we are departing the 250 meter holding point, now actually just under 240 meters and closing at a rate of about 0.3 meters per second. Of course, very shortly we're going to be crossing the keep out sphere. This is a sort of 200 meter just sort of general line drawn around the International Space Station, but it's a pretty significant milestone once we cross the 200 meters. Now, Chad, what does that mean, the keep out sphere?
Essentially, we treat the keep out sphere. That's the big crossing point. Whenever we're coming in with Cygnus, we get confirmation. The crew and everyone on board is under the understanding that we're coming in at this point, and the ability, you know, once we get to the 30-meter hold point, they'll have the ability to send us on an abort or retreat or whatever they need to do to sort of help control the safety of the crew on the ISS. And we also obviously have that capability from the ground as well. But the 200-meter point is just the point of safety for the crew, just to keep everyone in the awareness of we're coming in for the closer 300 or 30-meter as well as the final capture point.
And of course, we're closer now, just crossing 215 meters away from the space station. 15 meters to go until we cross into the keep out sphere.
Houston Station, hold command is disarmed.
Houston copy is checking. Cygnus PCS command checkout was successful. Begin monitoring approach from 250 meters per step 5 in 1.102.
Houston Station for Block Bravo at 193 meters, no change from the last report.
Houston copies, 193 meters and no change from last report. Thanks.
So you just heard confirmation from the crew aboard the International Space Station.
Cygnus is inside the 200-meter keep-out sphere. Crew now has the authority to issue an abort if no comm with MCCH, and the light is outside the corridor.
Station copies.
Again, we are inside the keep out sphere now, 183 meters and closing into the International Space Station. Now we're close enough. And for protocol, the space station crew has again a better view of the Cygnus. We're getting a view from inside the space station, looking at the Cuckoo workstation.
80 meters, Block Bravo, no change.
Houston copies.
Now, within the keep out sphere, the crew has the ability to issue an abort, because besides the communication and telemetry they're getting from this screen, they're also looking at the window of the cupola itself, the bay window that's facing downwards on the Earth, and they have a great view of the Cygnus and the robotic arm, as well as the controls, in order to capture the vehicle once it arrives at the capture point just 10 meters away from the space station. So again, crossing the keep out sphere after departing the 250-meter holding point. Next holding point at 30 meters. A lot can happen in that time, and Chad, you actually work with your team to sort of run through simulations of what could possibly happen in this time.
158 meters, no change on P1 lower outboard, S1 lower outboard starting converge, maybe 3 vehicle widths to the port and a half a vehicle length to the starboard. Everything else is nominal.
Houston copies. We're expecting the trend to continue.
Reports from the station looking good. The Cygnus again oriented in line with the space station, approaching to the 30-meter holding point. Now just crossing just below 150 meters away from the space station at a range of just about 2.2 meters per second. Again, flight control teams here are experts in its approach, going from the 250-meter holding point to the 30-meter. Chad Davis sitting next to me being one of them. Now, you run through simulations and look at possible scenarios in which things can happen, and what are some of the things you're training for in this scenario between 250 meters and 30?
Essentially what we do whenever we're doing joint simulations with MCC Dulles and MCC Houston is we'll look at different activities that can happen throughout the joint operations activities, not just between the 250 to 30, but for instance on this one we might throw in a malfunction that would have to do with the prop system, or they would have an indication of a latch valve open that wasn't supposed to be open, or vice versa. So that forces multiple groups within the team to look at their systems, and it also forces the mission director as well as the flight director to basically manage their teams on how they want to work that particular situation and resolve it, take it to a resolution. So for this instance, if we were to have a latch valve issue, then of course they would go ahead and stop the ascent coming in potentially, or take it up to the 30 and hold there. But it's always good from our training team perspective to see the dynamics of the team work together and work through whatever the malfunction or problem is that we throw their way.
Good to know that the teams behind the Cygnus vehicle itself and the operations, just as we're doing now between 250 and 30 meters, to know that scenarios have been thought of, and you guys are experts in its approach now. Everything right now, of course, looking perfectly nominal as we're getting closer to the 30-meter holding point.
Houston Station, 125 meters, Block Bravo, no change, either monitor.
Houston copies.
Houston Station, 100 meters, P1 lower outboard, no change, S1 lower outboard, 2 vehicle widths to the port, half vehicle length forward.
Houston copies all.
Now the Cygnus crossing beyond the 100-meter point, you're seeing views from the space station looking down at Cygnus as it's just under 100 meters away from the space station. Again, we're looking at the 30 meters as the next holding point for that vehicle. In the meantime, we're handing over video communications back here in the room, just monitoring Cygnus's progress towards that 30-meter holding point. You can see just before we cut away and lost the signal, we were seeing the views from Cygnus, but it has been illuminated for quite some time, even in the dark pass. That's due to a high beta angle. You can see here on the map the beta at the top left of the screen. Basically, the trajectory of the space station and Cygnus as it's orbiting around the Earth is sort of following the Terminator line and skimming just at the edge where the sun may be peeking over. We may see a little bit more illumination than normal as we're in this trajectory and into the night pass. Again, looking to the space station right now, 252 statute miles above the Earth. We're actually over the United States right now, just as we're passing east of Brazil. We'll cross into the an orbital daytime, but we'll have some nice sunlit views of the Cygnus throughout that time.
P1 lower outboard, S1 lower outboard, we've lost sight of the vehicle in darkness.
Houston copies.
All looks nominal out the window.
Houston copies, all nominal out the window.
Of course, the crew reporting loss of sight of the vehicle. You can see from the space station's camera just a little bit of glimmer off the side there, and the LEDs shining from the Cygnus vehicle. Again, into an orbital nighttime, we'll still have dim views of the Cygnus, but maybe a little bit more light than usual. Cygnus vehicle now less than 75 meters away from the space station.
In station at 70 meters, no change. P1 lower outboard, S1 lower outboard, we opened up the iris a bit and it's converging. Looks like it's offset about a half a vehicle width to the port. Well, that was nominal.
Houston copies.
Now the crew aboard the space station, again, looking through the windows of the cupola, they have a pretty good view, but the camera exposure not picking up, the camera that's collecting telemetry as Cygnus is approaching, just needed to open up the iris a bit. You can see reporting just a little bit off from the shape of the vehicle. You can see there off to the right, telemetry just a little bit off, but this is perfectly nominal upon the approach, and you can see Cygnus just about to cross over into 60 meters away from the space station. Again, 30-meter holding point is our goal. Now the shape is sort of rectangular, maybe sort of a tin can shape of the Cygnus vehicle. Now, is there a reason for that, Chad?
Well, essentially what you can see is the Cygnus is made up of two elements. The first being the tin can you referred to as our pressurized cargo module, and that's where all the payloads that we're bringing up to the ISS is stored inside in a controlled environment. And then, of course, you have the second element, which is the service module, and that's primarily the brains of the spacecraft. It's got all the major subsystems, from the propulsion, the electronics, the avionics systems, the GNC, the flight computers, all the brains that make Cygnus fly the way it flies. And then, as well as the prop system is distributed between the service module, and it has some of the RIA attitude control motors on the PCM as well, just for control of the pitch, yaw, and roll of the spacecraft. But again, it's two primary elements that make it up, and as it gets a little closer, we'll be able to see those a lot more clearly.
A little bit hard to see from this angle, but just sort of behind the vehicle, that's where the service module is, the one you're talking about, but or the service component with all the sort of brains, as you said, of the vehicle. But there's also solar arrays that are sticking out the edge, sort of perpendicular, I guess, or to the view that we're seeing. So they're a little bit flat, but those solar arrays are a bit interesting as well.
Correct. Those are our ultraflex solar arrays that we started flying since the OA-4 mission, and we switched from the rectangular ones that you saw on the earlier vehicles to help get a little bit of a mass savings, and they provide pretty much the same amount of power, but it saves us mass on the spacecraft, which means more cargo we can deliver for our customer NASA.
More cargo, the better. Again, 7,400 pounds of cargo aboard, including science experiments, as we talked about before.
Right over St. Petersburg, on and on P1 lower outboard. S1 lower outboard continues to converge, half vehicle width offset to the port side.
Houston copies all. We like that report.
You can see a little bit of glisten off the left side of the vehicle right there. Again, at that high beta angle as we're orbiting the Earth, getting a little bit of sun even during an orbital nighttime, giving some good views and telemetry from this Cuckoo workstation that we're looking at right now. 50 meters in closing. Again, the 30-meter holding point is the next milestone. A little hard to see, but we're crossing over the last bit of the United States, just the southern tip of Florida, about to head over the Caribbean, over Cuba, and then over South America. It'll be just east off the coast of Brazil, possibly Uruguay, that we'll start seeing more and more sunlight as we, again, are at that high beta angle, a little bit of sun glistening off the Cygnus as it approaches towards the 30-meter holding point, still 45 meters and closing, even getting some sun now.
Houston Station, 40 meters on and on, P1 lower outboard, S1 lower outboard, no change.
Houston, copy all.
Just heard the report from the crew. 40 meters in closing. Again, 30 meters is our holding point. Just under 10 meters to go. Again, we're at that high beta angle now, crossing over the Caribbean, soon over the northern coast of South America, 250 miles above the Earth. Still at that high beta angle, so just a little bit of sun peeking over the terminator line as we're in an orbital darkness. Hard to see, but once we're getting closer to the 30-meter holding point, 32 meters just about, and closing, the rate has slowed down significantly. We're now just about 0.04 meters per second as we're getting closer to the 30-meter holding point to slow down and hold at that position.
Station Houston on 2, confirm 30-meter hold and set up for capture per step 6 in 1.102.
And work.
A great view of Cygnus holding at the 30-meter holding point.
And at 30 meters on and on P1 lower outboard, S1 lower outboard, no change.
Houston copies. Understand the report, and we'll stand by for your readiness report.
So again, confirmation from the crew. They're looking at good telemetry as this Cygnus is holding at 30 meters. Space station is 250 statute miles above the Earth, just crossing over Venezuela right now. We'll be entering into an orbital daytime here soon, as we're still getting sun across the terminator line. Again, the space station and Cygnus flying at a high beta angle, so a little bit of sun coming from over the terminator line as we're flying over South America right now. Ground teams will assess the vehicle health and status at the 30-meter holding point before departing to the capture point. That's just about an approximate 10 meters away from the station. So the crew members aboard, that's Scott Tingle as the prime robotics operator, assisted by Ricky Arnold. Again, Norishige Kanai looking at telemetry from the inside as well. Will be using the station's robotic arm to actually grapple the vehicle. Great view of Cygnus as it's holding at 30 meters. Again, just assessing the health and status as we're about to depart 30-meter holding point to get into its capture position. You can see a lot of the features of Cygnus as we're at this close angle. Chad, can you pick out some of the it looks like was it a LiDAR component?
Yeah, I was going to say if you sort of look in the center back area there, the service module itself, you can see a couple of those smaller boxes are our LiDARs we're using as we're coming in. And a second ago, it looked like you could actually see the laser, the light as part of the LiDAR system itself. It's taking its ranges firing toward the ISS. Also, if you look in the upper portion of the back area of the service module, sort of looks like a white rectangle area, a little bit larger. That's our nanoracks deployers were following the completion of the cargo resupply mission. We'll be departing the station and deploying some nanosats for our customers, and that's a deployer mechanism we have mounted externally to the service module.
So as Chad was discussing,
Approach to the capture point.
Houston copies. Station Houston on 2. Cygnus is ready to proceed to the capture point. Expect approach to resume shortly.
Station copies.
And at 30 meters, everything's looking good. So very shortly, Cygnus will depart that 30-meter holding point and get closer to the station. You can see the robotic arm is already in position to get ready to capture the vehicle as it gets into its capture position, just about 10 minutes away from the or 10 meters away from the station. It's hard to see now, but you can see the Cygnus has already begun that phase, departing the hold position and now beginning its final approach.
Station Houston, Cygnus has resumed approach to the capture point. Monitor approach within 30 meters per step 7 in 1.102. The crew is primed to issue retreat if the primary range is less than 6 meters.
Station copies.
So you can see the telemetry from the Cuckoo workstation.
Bravo, both cameras on and on.
Houston copies, both on. Good report.
So the crew aboard the International Space Station will continue to monitor the progress of Cygnus as it gets closer to the capture point. You can see 26 meters and closing into the point where it's going to get closer and closer to that robotic arm that you can see sticking out from this view of the Cuckoo workstation that's providing telemetry of Cygnus as it is approaching closer to the station. The station's robotic arm already in position, getting ready to capture Cygnus once it arrives at the point just in front of the station's robotic arm.
25 meters.
Houston copy is on at 25.
Crew members aboard the station in the Cupola's workstation right now are getting a good view of Cygnus, just reporting progress from their view, making sure it matches with the views from here on the ground. You can see the space station and Cygnus flying near parallel to that terminator line. You can see just darkness above from this view and the light below. This is that high beta angle that we were discussing earlier that allowed the Cygnus to remain illuminated as it was still in an orbital daytime. You can see we're flying almost parallel to that line at this time. Great views of Cygnus as it's getting closer to the station. You can see just the bottom right corner, as Chad was describing before, the LiDAR system that's providing communication and telemetry of Cygnus to the station. Just at the bottom right, that's the service module, and there's a lot of components as we were discussing earlier, but there's a sort of a blinking red light, and that blinking red light is actually the laser firing and providing the communications from Cygnus to the telemetry from between Cygnus and the International Space Station. Ultraflex solar arrays just below that, illuminating and gathering power in from the sun as it's approaching the International Space Station towards the capture point, just 10 meters away from the space station. Space Station and Cygnus now crossing into the over the Atlantic Ocean, 255 statute miles above the Earth, just east off the coast of Brazil and Uruguay.
Houston on and on at 20 meters.
Houston copies, on at 20.
And Gary, if you notice on this view, you can see at the very aft end of Cygnus, the probe and the PBGF, that's the power video grapple fixture that the SSRMS, the robotic arm, will reach out and grab a hold of Cygnus with. It's a real clear view of it right now off the aft end of the service module.
That's right, we're looking straight down from the space station. The camera's looking sort of down, and you can see the Earth below. It's just at the back there, that little pole sticking out. Once it gets into position, you'll get a different view, and that's from the view of the robotic arm itself. It won't look like a pole from that view. It'll look more like a dot, and that's actually the line, the probe, as you're saying, that actually helps them to guide the robotic arm into into capture the vehicle. Again, we're looking good right now. Arriving at the still going for a 4:20 capture time as we're approaching the capture point just 10 meters away. Great views now now that we're over the South Atlantic Ocean, 258 statute miles above the Earth right now. You can see this is the camera view from the station's robotic arm. As we were discussing before, we were getting some views right straight down onto the Cygnus. Now this is the view as the Cygnus is arriving at the capture point. The Cygnus itself is just about 15 meters away right now.
Houston copies, on at 15.
Crew reporting the same number, just about 15 meters away as it continues to approach into its capture position. You can see in the back there the service module components, as we were discussing earlier, that provide sort of the brains of the vehicle. To the left there, that white structure is the NanoRacks CubeSat deployer that will be used to deploy CubeSats after Cygnus has left the station and deploy CubeSats around low Earth orbit.
Yeah, and there's a good view. You can see the actual LiDAR boxes right beside, to the right of the CubeSat deployer. It's a good view of those as vehicles approaching.
Ultraflex solar arrays coming into view now. You can see on the left and right the gold structures. The grapple fixture is that sort of three-pronged circle that you can see just at the lower back end of the Cygnus. And the white straight line with the sort of circle or pin in the middle, that was that bar that was sticking out before. That'll help guide the station's robotic arm into capture the vehicle here in a few moments.
Station Houston on 2, confirm capture point hold per step 8 in 1.102.
Can work.
So confirmation here from the ground that the Cygnus has arrived at the capture point. Again, we're looking at 12 meters away from the space station now, but you can see its position just in front of the robotic arm. They'll do a poll here in Mission Control Houston for a go, no-go to proceed with that arm moving closer and closer to the Cygnus that's now currently holding.
All of step 8 at 12 meters, and we've been seeing the intermittent TDRS to VVLOS. I'm sure you guys have. Is that an issue?
Checking. We copy, and no concern on TDRS to VVLOS.
Copy that. Thank you. Crew is ready for Cygnus capture.
Houston copies. Stand by for capture. Station Houston on space to ground 2. You are go for Cygnus capture sequence, step 4 in 1.110 Cygnus capture. Begin monitoring the backaway cue card.
Didn't work.
So everything going very smoothly as we're transitioning into move into the capture point. Cygnus currently holding just about 12 meters away from the space station, right in front of the station's robotic arm. After the polls here in the room, looks like all teams here are go for capture. And then we'll just wait for confirmation from orbit. Scott Tingle and Ricky Arnold inside the cupola workstation, working the station's robotic arm. The camera view that we're seeing right now will start getting closer and closer to capture the Cygnus vehicle today. Cygnus holding pretty steady right now. The space station and Cygnus, 263 statute miles above the Earth, just south of the Atlantic Ocean, about to pass over the southern coast of Africa, and then past that into the Indian Ocean. Cygnus vehicle holding rock solid in its position just over 12 meters away from the station right now. Robotic arm in position. Scott Tingle and Ricky Arnold in the Cupola workstation aboard the International Space Station right now, flipping the switches, getting the arm properly configured to begin moving the arm closer and closer to capture the Cygnus vehicle today. Cygnus vehicle seemingly anchored into place as its rates are rock solid, holding in its capture position just over 12 meters away from the space station. Now where you can see the arm itself is in motion, slowly going into capture the Cygnus vehicle today. You'll hear a series of status updates and commands as we get closer to capture the vehicle today. Three meters and closing. Free drift is executed on the vehicle. Two meters and closing. One meter left. Robotic arm is over the pin. And with that, we have capture 4:26 a.m. Central Time as the station and Cygnus fly 264 statute miles over the southern Indian Ocean. losing video communications. But again, we have a successful capture of today's vehicle, the Cygnus Orbital ATK Cygnus cargo craft, on its 9th contracted mission to deliver cargo to the International Space Station. You can see the congratulatory handshakes at Dulles, Virginia, at the flight control teams there at Orbital ATK.
Capture reconfig.
Houston copies. We understand we are go for Cygnus post-capture reconfiguration. Excellent job, guys. You've got a whole team down here in Houston with big smiles on their faces, and I know I can say the same for the folks out at Dulles and our partners around the world. Great work.
Thank you. It was a beautiful day to grapple the spaceship. And special thanks to Justin and Tim Marinos, who put all this robo training and motion into work to success. Thank you. Nice done.
Houston copies. Justin just gave me a thumbs up, and we'll pass the word on to Tim.
Some congratulatory words and specific callouts from the crew aboard the International Space Station. Again, it was Scott Tingle and Ricky Arnold in the Cupola workstation today, working at the controls of the station's robotic arm to bring the arm in to capture the Cygnus cargo vehicle today. Again, that capture time was 4:26 a.m. Central Time. The Cygnus vehicle and International Space Station were flying 264 statute miles over the southern Indian Ocean. With that, the teams here in Mission Control Houston will start prepping for post-capture timelines and procedures. Robotics officers on the ground will maneuver the station's robotic arm to position Cygnus just under the berthing mechanism of Unity at the nadir port, the Earth-facing side. That's where Cygnus will call its home until July, before it departs with some disposable trash and burns up over the Pacific Ocean. So with that, we have, again, a successful capture of the Orbital ATK Cygnus cargo craft on its 9th contracted mission to deliver cargo to the International Space Station. Congratulations to the teams here in Mission Control Houston, and of course the flight control teams over in Dulles, Virginia, with Orbital ATK's flight control teams. Congratulatory handshakes again delivered there as a successful delivery to the station was accomplished. Now we'll delay coverage for now and come back later to begin coverage of berthing the Cygnus cargo vehicle to the International Space Station. That coverage again begins at 6:30 a.m. Central Time, 7:30 Eastern today. We're looking at a berthing shortly after that. I'd like to thank Chad Davis for coming on console with me today and sharing his expertise of the vehicle itself, the Cygnus cargo vehicle, as well as providing some insight into the mission operations on that side. Chad, thank you very much.
Sure thing. I appreciate you having me.
With that, we'll wrap our coverage for today's operations to capture the Cygnus cargo vehicle, delivering 7,400 pounds of supplies, food, and experiments to the International Space Station. This is Mission Control Houston.